And on chapter 8, section 1, we're going to deal with sequences and summation notation. In this chapter, we're going to deal with sequences and series a little bit, just so you know that. But the first day, we're just going to talk about sequences and summation notation. First of all, what is a sequence? A sequence is basically just a pattern. Okay, so when you look at a list of numbers, is there a pattern that is forming? So when you're looking at this, first of all, the three dots at the end of it mean that it goes on forever in that pattern. But basically all I'm looking at is how are they getting the next number. So I went from 2 to 4 to 6 to 8. You can say that they're adding 2 or whatever, but the one way to kind of look at it is this is my first term, this is my second term, this is my third term, this is my fourth term. How would I make a 1 into a 2? Well, I either add 1 or times it by 2. If the pattern exists, it has to be done for all 4 of them and then carry on that pattern. So then I would say, well, how do I make a 2 into a 4? I don't add 1, I got to multiply it by 2. So what ends up happening is we're just saying 1 times 2, 2 times 2, 3 times 2, 4 times 2. Our pattern is designed by saying 2n. Okay, n is going to be our variable where we're just plugging in the numbers and seeing what we get. So just so you know, that's kind of what a sequence is basically just a list or a pattern of numbers. When you're looking at something like this where it says find the terms of the sequence, a lot of times they'll give you a formula and then they'll say something like find the first 5 terms or 4 terms or whatever it is. When they're asking you to do that, if I said find the first 5 terms, I'm putting 1 in for n and seeing what I get. So 2 times 1 is 2, minus 1 is 1. Then I do the next one. Okay, where 2 times 2 minus 1 would be 3. 2 times 3 minus 1, 5, and so on. So if they ever ask you for finding the first 5 terms and so on, then we just keep going on from there. So just so that you are aware of it, that's kind of what they mean by finding the terms of the sequence. If I change the equation to something like this, again, if they say find the first 5, I'm putting 1 in for n and seeing what I get. In this case, I have 1/2. T sub 2, I'm putting 2 in, and I get 2/3, and so on. So just so you know that that's what they mean by that, is they're just plugging in the numbers to see what we get. If they give you a formula like that, that's typically what they're going to ask you to do, is they're going to ask you to plug in the numbers and tell me what you get. If they give you something like this, for instance, if they give you something like 1/2, 3/4, 5/6, 7/8, they're going to ask you what's the equation or what's the sequence, what's the formula for it, or the nth term. Anytime they say nth term, they're looking for the formula. Now, with my students, a lot of times I tell them to, when you're given a fraction, look at it as the top versus the bottom. Okay, don't look at them as trying to make a whole thing. Just look at do the top and the bottom separately. So if you look at, again, this is the first term, this is the second term, this is the third term, this is the fourth term. Well, 1 into 1, that's fine. When I have a 2 there, we already saw that was going to be 2n. But if I put that in there, again, if I just did n, if I put 2 in there, that does not make a 3, that would make a 2. So how do I generate 1, 3, 5, 7? It's always 1 less than the even numbers. So if you went 2n minus 1, now I come up with my equation. This part will be the hardest part that you'll have to ever do when it comes to these, is trying to come up with the formula. Sometimes coming up with the formula is the hardest thing that you have to do. So if I give you another one, again, this is the first term, the second term, the third term, the fourth term. How am I generating those numbers? Well, if I look at not just adding and subtracting or multiplying, dividing, if I actually look at them as squares, that's 1 squared, 2 squared, 3 squared, 4 squared. So really what I'm saying is n squared. Okay, so as far as coming up with the pattern, those are going to be kind of the hardest things that you're going to have to do when you're finding the nth term of a sequence. Okay. After that, in our section, they talk about recursive formulas. Recursive formulas means that it's based on the previous answer. So when they give you a recursive formula, generally speaking, you'll see something like this right here. This is the part that means recursive. The a sub n minus 1 just really means the previous answer. They will always give you a starting point, so that way you don't have to worry about what number do I start at, because if I start that at a different number, it's going to give me a completely different list. If you just started at a random number, it's going to be a different list than maybe what the answer is asking you for. So when they ask you for the first 5 terms, first of all, they give you the first one. So the second one, and I'll show you how this works. If you're going to put 2 in for n, that's 3 times a sub 2 minus 1 plus 2. Well, 2 minus 1 is 1. So what they're telling you is, hey, what's a1? Well, a1 they were given to you as 1. So now all I'm doing is, and I hope you notice this, but this spot right here is going to be the previous answer. So again, remember your order of operations. 1 plus 2 is 3. 3 times 3 is 9. Then if I do the third term, again, it's the same thing. But if I figured out that this is the previous term was 9 in this case. So I'm just going to put in that thing. Anytime you see that n minus 1 in the sub part of the number like that, that just means previous answer. So for this particular one, 9 plus 2 is 11, and 11 times 3 is 33. And I would keep going. A sub 4, 33 plus 2, 35 times 3 is 105, and continue. So just so that you are aware of it, that's what a recursive formula is. One of the most famous recursive formulas is the Fibonacci sequence. And that Fibonacci sequence is determined or found like this, where you take n minus 1 plus n minus 2. What that means now when you get a minus 2 is it's the previous 2 answers. So again, if I give you the first one was 1 and the second one was 1, find the third term. Well, if I put 3 in for n, what's going to end up happening is I got f of 3 minus 1 plus f of 3 minus 2. 3 minus 1 is 2, and 3 minus 2 is 1. So they're asking you to take the previous 2 answers, or in this case they're both 1s, to equal 2. Then if I go to the fourth one, that's saying f of 4 minus 1 plus f of 4 minus 2. Well, 4 minus 1 is 3, and 4 minus 2 is 2. So now they're looking for, again, the previous 2 answers. So f of 3 was 2, and f of 2 was 1, and I get 3. And then I could continue to keep going on that forever as far as I needed to go. The next one would be the previous 2, which would have been 2 plus 3 is 5. Then the previous 2, 3 plus 5 is 8, and so on. So just so that you are aware of it, that's what they're going to ask you to do when they ask you for those, is find how many ever terms that they ask you to do. Okay, so that's how the Fibonacci sequence works. Then the next thing that they have for you in this first section is partial sums of a sequence. Partial sums just means that you're going to be adding together some of your answers. So if I say find the first, if I give you an equation and it says find the partial sums, 1 through 5 or something like that, then all you're going to do is you're going to keep just adding the numbers together. Let me find one like that, so you know. Well, if I just give you something like this, 1, 3, 5, 7, 9, dot, 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 and they say find the first partial, or 6 partial sums, S sub 1 means I take the first term and I add it. Well, the first term is just 1. If I say find S sub 2, I'm asking for the first 2 terms, which is 1 plus 3 or the answer would be 4. S sub 3 would be the first three terms, so 1 plus 3 plus 5, which is 9. S sub 4 is 1 plus 3 plus 5 plus 7, which would be 16. And so all you're basically doing is just adding the first 4 or 5 or how many ever it's asking you to do. This number right here, the sub number, that will tell you how many ones it wants you to add together. Okay, so if they say find the partial sums and they're giving you that list, that's what they want you there. How many that they want you to add together. The other way of writing that, or the other way of looking at that, is in what they call summation notation. Summation notation has this Greek letter of the alphabet, sigma, and sigma stands for summation. Summation is the long version of add. So they're going to give you something like that, where this right here is the starting point, and this number up here is going to be the stopping. Okay, so that's kind of a starting and a stopping, and then they're going to give you an equation, something like if I went k squared, something like that. You know, they're going to give you the equation. This is going to be the letter. This will be a number of which we stop at. So if they said something like this, where they said k equals 1 to 5, and they say k squared, then that means I have to put every number in from 1 to 5, and then when I get done, I'm going to add the answers together. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. And that's again where I stop, because that top number is what I stopped at, or where I'm going to stop. Now from here, I add everything together. 20, 30 is 50, plus 25 is 55. And that's my final answer. So it's very similar to partial sums, except for this one, it's going to have one answer instead of multiple. But as far as how sigma notation works, the bottom number tells you where to start, the top number tells you where to stop, and then once you get all those, you just add them together. So anyway, that's section 1.